This video is about number 6 on the quiz. So what we have to do is find how to make a buffer with this acid with a pH of 4.0. If you look at Henderson-Hasselbalch, basically what you're doing is 4.00 equals 3.73, which is a pKa of the acid, plus the log of A minus over HA. Okay, so that's what we're trying to find. And if you look at this ratio right here has to be greater than 1 because we need to increase the pH. So we need more A minus than we have HA. In other words, we need to produce more base because we need to increase the pH, which in effect is adding more base. So this is what we'll say. If you subtract 3.73 from both sides, we'll get 0.27 equals this ratio. You do 10 to the x on both sides, and what you get is you get this ratio of 1.86 equals A minus, the ratio of A minus to HA. So we need more, what it's saying to us, we need more base than acid. Okay, so how do you go about that? So what I'm going to do is I'm going to work in moles. So I'm going to start off with HA plus OH minus yields H2O plus. I'm going to say I have 0.01 moles of this stuff. Well, how did I get that? Oh, I know that 50 times 0.2 moles over 1,000 mLs equals 0.01. And we'll put some more zeros in there. So that's coming from here. Okay. We have nothing here, and we have basically nothing any place else. Okay. So as we do this, though, we'll go minus x and plus x. Because that's what we need as a ratio. So what we end up with is this 0.01 minus x. And this will be just x. Well, so we're going to use this equation and basically say 1.86 must equal A minus, which is x, over 0.01 minus x. Now, you might be asking, well, you're using moles. The Henderson-Hasselbalch equation is in molarity. That's true, but it's all in the same beaker. So the mils or the volume of both of these things are exactly the same. So we can use moles instead of molarity. I think it just makes a little bit more sense in this problem. So x ends up being, by the way, 0.0065 moles. Now, this moles of your base. Well, where did the moles of base come from? Well, it must have been moles. It came from moles of NaOH. Because if you look at this initial problem up here, this and this are exactly the same. They're 1 to 1. So if we want x moles of A minus, we better have x moles of OH minus as well. So we're going to go ahead and do this. We'll say, well, I know that I want 0.0065 moles of NaOH. So I know the molarity of NaOH I used, and that is 0.1. So I'll put 1,000 moles up here, 0.1 down here, and what I'll get is 65 mils. So if I titrate this with 65 mils, of NaOH, I should get a buffer of 4. Now we'll test that, but it sort of makes sense because at 50 mils, that would be my perfect buffer. And we already said we need more base than that, so 65 sort of makes sense. What I'm going to do is in the next video show you the test that I'm going to make sure this all works.